Hello and welcome. While this topic might seem small, I can assure you that it is a massive part of the process of making our V2 Series kits. It's the countersink. The main purpose that we do the countersinking is for the aesthetic value of the V2 Series kit, as well as our caps that we manufacture that you guys customize per order, has your serial number, codes, your kit edition colors, so on and so forth. They will sit on the end of a finished kit, and if we didn't countersink the bolts, we wouldn't be able to attach the caps. So massively important that the countersinking is done properly. Now you'll see there's 2 holes in the top, and there's 2 holes on the bottom, and then on the back side there's 3 holes where we bolt on the main bearing assembly, which is also the part that bolts to your door to go up and down. Now we used to outsource that local, but we used to outsource it, and it was costing quite a bit of money on each kit. So in our attempt to lower some costs where we can, but having to buy the equipment doesn't seem like it's lower now, or yet at least, but it will eventually pay off. However, nonetheless, these countersinking bits, the head of our bolts that we use is 82 degrees, and we have to get them to where, as you see, they're flush so nothing can catch, grab, so on and so forth. That's for the back as well as the front also. Now these countersinking bits are pretty expensive, ranging anywhere from $60 to $90 some dollars plus sometimes, depending on like the coating, the finishing, things such as that. We try to use higher quality ones that are tin coated to just make the life. The material that we're countersinking is 836 steel, so it's a very, very hard material. Using high-speed steel can work as far as the bits material can work, but we prefer like a tin coated or a cobalt material, which prolongs the life of the actual countersinking bit itself. So this is what our countersinking bit looks like. It's a 3/4 inch, 82 degree, tin coated, which is not tin like flimsy, thin tin that you're thinking of. Tin coating stands for titanium nitride, and what it does is kind of just makes the surface more durable, last longer. Now there are a variety of these available with how many flutes is what they're called are on there, up to like 6, 7 I think. Some of the higher ones that I've seen. Those chatter, which bounce around, jump around, and don't give you an ultimate smooth surface, which obviously is what we want. Because basically, when this is bolted through, we want, and this is why it's imperative that the 82 degrees is met in the material as well as the head of the bolt, because we want the pressures to evenly distribute to the part itself. We get, on average, like using a high-speed steel, we might be lucky to get anywhere from 20 to 40-ish countersunk holes using a bit like this one. This one was like, I believe, about $98, $99, something like that. You might be able to get 60 to 80 countersunk holes on this. They do eat up pretty quickly. Just one of those things where it's an added cost in the consumables that it's kind of unavoidable for the design of our kit. We had to modify our mag drill. There was a big, huge magnet on the bottom. So this is the electromagnet that was on the bottom or the base of our mag drill. We've obviously had to remove it, cut it off to fit our application and or our build table, I guess you could say, to make sure that we can slide in the kit to make sure we have enough clearance to get to the holes and give us a straight on flush attack direction on being able to put the countersink holes in. So ours is slightly modified, but we had to do what we had to do to make it work for us. Typically, these 2 magnets right here, when the drill is turned on, will apply and magnetize itself to the actual kit. The reason why we had to cut it is because one of these holes, the only real significant way to get the magnet enough of the material to magnetize itself to, it just wasn't enough. So we had to kind of rig up our own type of system, I guess you could say, to be able to get to it. So magnet in our mag drill is gone. We don't utilize that, but it works still nonetheless. We bolt it down to the table. And this drill is freaking phenomenal. It's straight, it's flush, it's flat. It really doesn't take that long to countersink each hole, but it is a process nonetheless that every single kit goes through. We are thinking about adding one more countersunk hole to the frame piece, which is this hole right here, which is for our bottom shock mount, the spacer that goes to where the bottom of the shock mounts to. It's not that we need to, it's just to kind of continue the design or the aesthetic look of the kit. This is one of those OCD things for me, but each kit takes 14, currently right now, 14 countersunk holes, and that's a lot. And this thing, and this process is very, very messy. As you see, it just creates coils upon coils of thin steel that fly everywhere, and it's just, when we do our countersinking, a lot of cleaning, a very messy process. But at the end of the day, it creates what we are extremely proud of, which is the aesthetic look and feel of the V2 Series kit for the C8. So if you have any questions about our countersinking process, please don't hesitate to reach out, drop a comment, send us an email, give us a phone call. Also, if you'd like to see something that we do, or if you're curious about a process of something else along the lines of us making our V2 Series kit, definitely ask us and we can potentially make a video for you, or we'll just at least respond and give you the best answer we possibly can for whatever questions you guys might have. Until next time, please like, subscribe, and share. We'll see you on the next one.